think that we together are definitely so much more powerful than any of us alone. It's great to be in this community of like-minded builders.
I think this is a great opportunity for all of us to not only just continue to learn, right, but also support each other.
I end up after each session very encouraged to go out and build better homes.
I feel like we're pretty isolated, pretty alone as a high-performance builder, and two, as a woman builder. It's nice to, coexist with this great group of people that I've learned so much.
We are in the company of the best, and we will become the best as if we'll stay on this path. The market has come to us, the opportunity is there, and it's our time.
Fantastic. I think I saw some Indoor Air Plus award winners in that group of the Builder Benchmark group. Welcome. My name is Aaron Smith. I'm the CEO of EBA, and we're excited to have you join us at the 2020 Virtual Summit. Today's host is Gene Myers. Gene is the CEO of Thrive Home Builders and is the board president of EBA, and also leads our Builder Benchmark group. So we thought it'd be appropriate to lead in with a video on the Builder Benchmark group. Gene, welcome, and thanks for hosting today.
Well, thanks, Aaron, and good morning, everyone. It's bright and early here in Denver, and we're going to get off on the right foot here with Peter's presentation. But before I introduce him, I'd like to just say a few words about the Builder Benchmark group. If you're a builder in the EBA community, you're eligible to join into a Builder Benchmark group. And what this is a group of non-competing builders that share best practices, both business practices and building science practices, and green building practices. But it's kind of like what Glenn has said, it's really a chance to pull together with like-minded builders and pool our resources and problem solve and work through what's happening now. I think we launched just in time for the big shutdown, and I'll tell you what, this monthly touch point with like-minded builders is some of the best conversation and best thought exercises that I've had all through the pandemic. And so I would encourage you to contact Nancy or Aaron if you have an interest. And I think every participant of the Builder Benchmark group would give you an unqualified thumbs up that this is really worth doing. So now I'm going to dial back to pre-shutdown, and I ended up having dinner with Peter Pfeiffer at IBS last year. And somehow he's been around this green building movement longer than I have, and I had never met him. And it was a little bit like discovering a long-lost relative when I sat and shared my experience, and he shared his. And we talked about EBA, and he said, you know what, I'd like to plug into EBA more. He's certainly been around EBA for a very long time and honored by EBA. And so it's my privilege to be able to introduce Peter. He's going to give us the architect's perspective, and honestly, I think that's a missing perspective at EBA. We really need to be attracting our architects because we really need to be delivering homes that are not only at the pinnacle of building science, but also the pinnacle of design and beauty and function. And that's how we take our homes mainstream, is they're just so appealing in every way. And so I'm so grateful that Peter agreed to do this. So I want to encourage you to go on the Whova app and click on his bio. It's unbelievable, with things like chances to talk on the Today Show to John Q. Public, and really to be an emissary of green building to the entire population. But Peter's a professional architect, building scientist, and interior designer, property manager, and realtor practicing throughout North America. He graduated with a BS in Building Sciences from Rensselaer Polytechnic Institute and the University of Texas, where he graduated with a master's in architecture degree, emphasizing energy conservation and resource efficient design. As the founding principal of Barley Pfeiffer Architecture, a firm recognized nationally for its pioneering use of environmentally responsive building design and construction techniques, he continues to push design and performance to its next, better level. This includes healthy, low toxicity environments in medical facilities and private homes, energy conserving design and construction, and water conservation for residential and commercial use. EBA awarded Peter the Conference Chairs Award in 1994 for his career accomplishments in pioneering environmentally sensitive architecture, and then recognized him again for his 2016 at their annual convention. In 2003, the NEHB honored him with the National Green Advocate of the Year Award for his lifelong achievements in mainstreaming green building. Peter continues to chair the City of Austin Mayor's Task Force on Zero Energy Capable Homes, which in 2007 put forth the most stringent residential energy conservation and indoor air quality codes in America. Peter spent the last 4 decades developing and advancing pragmatic high performance, also known as green building methods, while also keeping a keen eye on high quality design. In 2004, he was named a Fellow of the American Institute of Architects for his lifelong achievements in mainstreaming green building, one of the first architects in the nation to be recognized for such. To complement this, in 2006, Residential Architect magazine cited him as one of the 10 most influential residential architects of the decade. In 2019, Peter was awarded the Green Superhero of the Year by Green Builder magazine. More recently, he was selected to speak at the prestigious South by Southwest conference addressing climate and social action. And so it's really, there aren't very many Peter Pfeiffers. And so it's a real treat and a real honor for us to have him again at EBA. And Peter, thank you for coming, and I really look forward to your presentation.
Well, thank you, Gene. And I just want to make sure you all can see the screen. Is it coming up?
Yep, it's on.
Great, great. Okay. Well, now all I have to do is walk through it. Give me just a second. I want to switch screens over to somewhere else. Well, I'll do it from here. Gene, and what are we seeing right now? We're just seeing the screen, right?
Yeah, we just see
okay. All right. Well, I have to have this obligatory slide to start off about the CEU is available for this session. And those of you who are architects, this would qualify for your sustainability credit that some of the states require. Look, the reason why I call the talk the rise and decline of the green building movement and what's real now is that this is a movement that really started, in my view, back in the 70s, and it gained some steam, you'll see, with Energy Star later, and then green building. And the original purposes of it was to help folks make decisions when it came to building their homes to make smart choices. And those meant smart programming choices and smart design choices, and be open-minded to things like passive solar design. The movement changed. It got very much based on things instead of thinking. And I want to just give you a different perspective on where I think it really needs to go now. So let's jump in. But my background, so you understand that perspective, no, Gene just gave a long bio about me, but this is important because I grew up in construction. I was one of 8 kids, and my parents had rental properties, and they had 7 sons, and we were the in-family maintenance and remodeling crew. So what that gave me the perspective of is not only how to do construction and remodeling, but how it works out over the years. We still own one of those homes that my parents had as a rental property. It's now 40 years that we've owned that home. And interesting enough, humbly enough, that was the first home I ever designed after the one that was on that lot burnt down. And boy, do you learn some lessons about about your architectural services when you have to own and maintain a home that you designed and had built for 40 years. So there's that construction background. There's the interior design aspect of what we do. My partner and I are licensed in that. And we got into interior design because interior design affects things like lighting and affects indoor air quality. So we couldn't just be architects without being interior designers. And then over the years, we became called on more and more by our colleagues for building science consulting. And for about 35 years, we've been doing that. So we're practicing architects who grew up in construction. However, at the University of Texas, I was really lucky to be introduced to a professor who was developing one of the first energy analysis programs that any of us started using, called working on DOE2. But actually, we did our own version, which was called the Dynamic Energy Responsive Buildings, DROB. And he was fantastic with the perspective he gave me, and you'll hear a bit about that. And then last but not least, I do a bit of development myself, and I own a number of buildings and old houses that I have to manage. And that's where I get to use them as my laboratory to see what works and what doesn't work out so well. If you're ever interested, talk to me about tankless water heaters and why I'm not so sure I'd do them again. But that's my background. Let's jump in. We do houses of all different types, from lower income homes here that still have good solar shading and good shading, a good protection from the elements, to high-end homes like you saw the cover. That's the front porch of one of the homes I've designed. Actually, it's my own home. And then we also are in what I call boutique commercial stuff. We do community centers for new towns around the country. This is one that's outside of the San Antonio area, where we have a large porch that's shaded and facing south, so they'll take in the breezes and to have fewer mosquitoes and be able to watch their kids in the swimming pool below. So we really do try to apply the sustainability and passive solar design principles to absolutely everything we do. Now, this is a professor who actually in the late 70s, when I was thinking about going to either MIT or Berkeley for my master's, I read about at the University of Texas, who was developing this computer analysis program. So I drove up from Houston, which is where I was living at the time, to visit with this man. And I loved some of the very practical things he said. And this is a good one. He said, think about what enhances your personal comfort. Then design the building with that in mind. And boy, if you really absorb that, it cuts through so much of the chaff. For example, in Austin, Texas, you would be much more comfortable standing in the shade than you would be with having a heavy winter overcoat wrapped around you, insulating you. So that tells you, don't get so hung up on the R values of your walls and your roof in this climate, but do shade your windows and do a shading umbrella type roof. Deal with the things that are important in your climate. Now, if we were in the mountains of Colorado, obviously that would be different, but it just helped us understand how to prioritize our clients' money. And when I really absorbed that statement, I was very impressed. And then, of course, there's this thing that Winston Churchill said about the environment shapes the architecture and the architecture shapes us. So let me show you one example of this art center we did a few years ago. You'll notice there's on the left-hand side, there's that Corten steel, that rusty steel shading device, because those windows face west. But these windows face east, where the art gallery is. So we designed the building so the things that would be used in the evening are on the east side, where it's cooler. And the things that would be used during the day on the west side had to be well shaded. So just right from the start, the layout of the building reflects being responsive to the climate. So here, the big open glass on the east side, the building's not occupied. The art gallery is not occupied in the morning. It acts as a great beacon for people coming off the highway to see what's going on. But here on the west side, you see we took a lot of efforts to make sure those windows had a fair amount of shading associated with them. So there's an example of, by design, trying to respond to the climate, but even by the original programming of the building, we were making sure we were responding to the climate. The origins of green building, it's kind of a neat story that I'm gonna just brag a little bit about, because that guy, Arumi, got a lot of us involved with this whole movement of using metrics to do more refined energy analysis and to guide our clients better. And mind you, this is back in the late 70s. I actually didn't come till 81. But out of that group of us and others, there was a volunteer group that created this program called Austin Energy Star. It was some volunteer efforts by some architects and engineers, and then people who worked for the utility department, because we had an issue here in Austin where the city wanted to invest in a nuclear power plant and the citizens weren't happy about that. So we looked at, well, what can we do? Can we create what we called at the time the conservation power plant? In other words, instead of building more power capacity, can we lower the consumption during the peak times of the day? And it worked. Austin Energy Star became the first municipal energy conservation program in North America, and the DOE recognized it and asked if they could ride on our coattails a bit, build what we built from or build on, and they took it and they created Energy Star from it. So when you hear the term Energy Star, understand that it was named after the capital of the Lone Star Republic, Austin, Texas. But it's a great program because what it helped us do is look at energy consumption the way you might look at the way you drive a car. Your car might get 20 miles per gallon on the highway, but it might only get 15 miles per gallon in the city if you drive, especially if you drive aggressively. Well, it's the same thing with buildings. How you use the building is every bit as important as where the building's situated and how well built it is. If you're somebody who is in great shape and relatively thin, you probably feel cold if you air condition the house below 78 degrees. If you're like many other people, you might need it to be air conditioned down to 73 or 74 degrees. So that alone starts telling you, all right, we have to put a little bit more emphasis on the efficiency of the air conditioning equipment for this house. But what it also showed us, interesting enough, was that in Austin's case, we needed to have almost twice the energy capacity in reserves just to handle about 100 hours a year. And that's when people were coming home to make dinner on a summer night. So July and August, Monday through Friday, about 4 o'clock to 7 o'clock, people are coming home and turning on their lights, turning down the air conditioning, and firing up their appliances. At the same time, the building they just left or wherever they just left is probably still running. So there's a peak that doubled the amount of energy we needed to have available to us. And that's why we zoomed in on rebates for air conditioning better air conditioning systems, and rebates for changing out your light bulbs with compact fluorescents. And then we went to the various appliance showrooms around town and put little blue stars on the more energy efficient models. And that way people could recognize, oh, that's a particularly energy efficient refrigerator. And that's how Energy Star started. But as we went along with this idea of managing consumption or managing demand, we also started using that same approach to deal with things like water conservation. We had a certain contract to pull water out of the lake that runs through downtown Austin from the Lower Colorado River Authority that was running out. So we knew it was going to be expensive to renegotiate the contract, so we wanted to see what can we do to reduce the average Austin citizen's demand for water more and more. And it worked. We found, frankly, that managing the way people use lawn sprinkler systems was the single most effective thing you could do. But I don't think we'll have time to go into the details of that today. I ended up chairing that program that was looking after the city's efforts. The program was called the Resource Management Commission. And under my tutelage, we had to look at what were we doing in terms of energy conservation, what were we doing in terms of water conservation. And then the third thing we ran into is what were we doing in terms of managing the waste stream, because our local utility or our local municipal landfill was getting overfilled and we needed to expand it, and that wasn't a popular idea. So that's when we thought, well, the landfill is being filled up very large percentage, I forget the numbers, maybe 44%, with construction debris. So we figured, we got to go out to the building community and get them in on this conservation issue. And so we changed the name of Austin Energy Star to the Austin Green Builder Program. And then it became the Austin Green Building Program to pull architects and engineers into the program. And that's how we changed, and that's how we formed the first green building program in the United States. And it's pretty neat because we never had to build a new power plant for about 25 years. And we we did expand that landfill, but we didn't have to expand it nearly as much. And we still have one of the lowest rates of consumption for water of any major city in America. So that was that's a little story about the origins of green building. And then came LEED for Homes, which I think was great. I called LEED the screaming young teenager wearing the bikini, standing on the street corner, jumping up and down, getting everyone's attention. That's good. They did a fantastic job at popularizing the concept of green building. But I wasn't happy with the checklist approach. I think it missed the mark. I mean, this is a LEED Platinum home in Houston, Texas. Any of you who've been to Texas realize that type of sunlight, unfettered, coming into a living space is going to be a horribly uncomfortable place. So I don't really care what the rating of the R value is of the walls, or whether or not those stones were sourced locally. What I do care is that the design doesn't work for this climate. How does a project like this get a platinum rating? And we began to see, as we got into the 90s now, in the early 2000s, what I call the pincushion home, where you would have just a standard home that's not really built well and certainly not built to respond to the environment, but they tack on a tankless water heater or a passive a solar system on the roof, or maybe even a wind turbine, and sell it as green. And we see that around the country. This is a place outside of Austin where you see those unshaded windows facing west, but yes, they've got solar panels on the roof. Heck, guys, just don't have your windows facing west that are unshaded, and you'll be better off than investing in solar panels on the roof. So we don't promote that. And I think, unfortunately, society has absorbed the idea of green building as a bunch of things you tack onto the house. But where I think green building presently is failing is we tend to portray an overly complicated approach to doing what we call green building, and it appears to many people to be too costly. I like the idea of KISS, keep things simple. And then there's the other misconception that the buyer thinks that everyone's already doing it as a standard matter of practice, so they don't really have to be very critical with their thinking and their evaluating of what this builder is telling them. And then I do believe it focuses too much on the minutia and misses the point about what really matters. For example, we got all into these details about an expensive green roof and how to do the best waterproofing and stuff like that. Well, what are we trying to accomplish with this green roof? If in our area it's simple radiation control, then there's a whole lot of other things that are a lot simpler and a lot less expensive that will be just as effective. So let's keep the goal in mind. And that's why I say, always ask yourself, why are you doing this? What is it you're trying to accomplish? Because I hope this one comes here, but this is an example. Look at this guy. His buddy's going to help him get his iPhone, right? No, he helped him get his stick. So the point is, think about what you're trying to do before you go do it. And then think about these basic tenets. I know these are mine, and I know they sound very simplified, but this is the way what I think green building boils down to. It's reduced consumption of stuff, whether that's energy, water, materials. It's improved health, indoor air quality is a large part of that, and reduced environmental impact. Now, we've only got one session today, so we can't talk about a day's worth of stuff. But in this particular talk, I am going to zoom in quite a bit on indoor air quality. Over the years, we changed the term from green building to high performance, at least for our clients when they were coming in, because there was a negative connotation associated with green building and greenwashing. So I said, look, let's change these goals or change the narrative a little bit so we could put it in perspective for people that they could understand. And so to me, it means lower cost of ownership, lower energy bills and water bills, less maintenance. It means improved health. That means cleaner indoor air, better humidity control, getting sick less often. Put the attributes in terms that the public can relate to. And then more comfort, better use of natural lighting, less glare, less eye strain, more even temperatures from one room to the next, and a more quiet building. And we continue to say, let's just keep it simple and try not to rely on gizmos and complicated things because they break and they cost money and time to fix. I don't mean to be coming down on tankless water heaters because I think they have their place, but I can tell you that if you really want to keep it running optimally, the amount of maintenance it takes to keep a tankless water heater running is a real expense. In our calculations, it takes about 25 years to pay for itself, a tankless water heater versus just a good tank type water heater. Now, this might be different where you are, particularly if you're in a very cold climate. Okay, so when we try to help folks prioritize the idea of what to do to make their home energy efficient, I think back to the old food pyramid that you might remember when we were kids from the Department of Agriculture that encouraged us to eat more, use more fruits and grains and vegetables in our diet, go a little bit sparingly for the meat and poultry and fish, and certainly be very sparing with the way we consume fats and oils and sweets. So that's it. Okay, great. So from our perspective, that means the base of the pyramid should be, don't build the house any bigger than you need to. Make sure it's tight. You can't heat or cool your entire neighborhood. And we'll get into tight and ventilating it right later. Make sure we respond to the solar orientation and use natural vegetation to protect the house when possible, or protect it from the sun and the wind. So those are the basic things that get baked into the house by design. Then you layer on top of that more efficient appliances and lighting. Those aren't quite as valuable because they're going to need replacement. They're going to break. The things at the base of the pyramid will never break. They're baked into the house, so to speak. And then after you've done layer 1 and layer 2, then you can look at producing your own power, maybe solar photovoltaics. And the reason why I do it this way is because still the most expensive stuff is at the top of the pyramid, and the least expensive yet most effective stuff is at the bottom of the pyramid. So that's a great way of helping our clients understand perspective. And here's some examples. Reducing air conditioning load is a lot more effective than thinking about buying the most expensive, the highest SEER rated air conditioner, or putting solar panels on the roof. So something like awnings, these fixed awnings above these windows on the south and west side of this old house we've renovated, cut the AC system's size requirement by 1/3. And they had some other advantages. They kept sun off the windows so you didn't have to close the blinds during the day to see what's going on. So there was better daylighting in the house, and there was less use of electric lighting. And they also kept water off the windows so the windows didn't get dirty nearly as much, reducing the maintenance on this house quite a bit. So that was by design. Now, this is an example of what too many people have been doing, and we say, don't do this. Think about this. Yeah, I know that butterfly roof design has been the popular rage again for the past 10 years, but look at the consequences of these houses. This is a neighborhood that's all solar panels on the roof, but yet they don't have good passive solar sun shading. If you just shaded those windows better by having a more appropriate roof design or some awnings over the windows, you would have less air conditioning loads, you have less lighting you need because people close the blinds, there's too much glare. Just shading those windows would save more energy every year than that solar system on the roof produces. So that's a pincushion house, and that's what we don't want to do. And then I started thinking as I got through going through my career more and more, that really what you can be if you're going to be a good consultant, and I would like to think an architect is a good consultant, to a client who's building the most expensive thing or probably spending the most amount of money on any one thing in their life, which is building a home, is we want to be the inspired generalist. We want to help not only our clients, but our builders understand the relationship between things. Like we all think here in Austin about a roof being important to keep the water out. Everyone does. But if you do the roof, that same roof, just a little bit differently, you can also make it so it keeps the solar radiation out. It becomes a shading umbrella, and we'll hit that. And then I always tell people, be careful about what you read on the internet. It's non-vetted knowledge source. You don't know if it's a function of a sponsored article because somebody's being sponsored by so-and-so, or you don't know if it really applies to your area. So keep a scant eye on things there. And then don't underestimate the value of discussing the obvious. For example, if we get all wrapped up in our value and what type of insulation we're going to use, but our windows are unshaded or the roof is a dark color, well, what have we accomplished? We've not made a green home. We've just made a lousy home that's got a lot of insulation stuffed in the walls. Now, again, this is for a cooling dominated climate, but I think you get the gist of what I'm saying. And so my view is green building is mostly just about building smarter and better and helping your clients make more informed decisions. When we start off with a client couple, we go through programming where they tell us what they want. And very importantly, we try to get into finding out why do they want that? Because there are ramifications to that steeply pitched roof that they like the look of, because we don't get snow loads here, and that will use up more material and it will make it difficult to shade the windows. People don't understand this. They have to have you as the guidance counselor for them, help them make smart decisions. Tall ceiling heights, I know they're popular, but it's more air to condition, more air to dehumidify, more air to heat. So people need to know that many of these things come with ramifications, and it's your job to help explain that to them. Once we get into program, and it starts off even with helping them select the best lot. If they're really interested in a passive solar home that's going to have good comfort and lower energy bills, find a lot on an east-west running street. And I say that because most homes, particularly in more dense neighborhoods, have the dominance of their windows on the front and the back. And if that's the case on an east-west running street, that means that most of your windows will face north and south as opposed to east and west. It's a lot easier to control passive heat, solar heat gain when your windows face north and south. So there's just a little example of some obvious stuff that often gets missed. But we did about 20,000 energy analysis of homes in the earlier part of my career for the production builders. And I can tell you, the exact same house facing west needed about 30 to 40% more air conditioning than if it were facing south. I saw that time and time again. The other thing we like bringing to our clients' attention is stop looking at the darn price per square foot. I know it's a popular metric that came about in the 80s, but it makes about as much sense as me asking you, gee, that's a good looking shirt you're wearing there. How much was that per square inch? It misses the point. What is the bigger point is what's the total cost of this project going to be? Construction might be about a quarter of the cost, but then there's maintenance and insurance over the next 20, 25 years that'll almost be as much. There's energy consumption too. So design with the total cost of ownership in mind. Now, I know if you've got somebody who your market is just people are buying and staying for a few years and flipping the homes, this won't make sense. But if it's somebody who wants a home they're going to hold on for a long time, this metal roof is a great example. At the time, it added about $6,000 to the cost of this house compared to a shingle roof. It added, I think that was about $30 more in their 30-year mortgage monthly payments. But because there are a few attributes to it. It'll be the last roof they ever have to put on. And because it was a class 4 hail rated roof, their insurance premiums were reduced significantly. And because it was installed in such a way to act as a shading umbrella, its energy costs were reduced significantly. So it actually costs less money to operate this house from the start because of those savings in energy and insurance compared to what it added to the mortgage payment. So there's some guiding we give our clients there regarding looking at the longer term ownership cost. But here's another obvious thing that it may be obvious to most of my audience, but not to the public, that paint colors on the outside of your house have a tremendous effect on its comfort, especially as it gets warmer and warmer in a lot of cities across the country. That light blue wall was 102 degrees at 4 o'clock in the afternoon, while the brown siding right next to it was 130 degrees. So if we're talking about insulation values and R values, the resistance to heat flow, there is a whole lot more heat that has to be resisted in that bedroom that's got the brown painted siding outside versus the bedroom that's got the light blue painting outside. You would need twice as much insulation to have the same comfort level in the bedroom that is having the brown paint on the outside versus the light blue paint. So these are super simple things, but people miss them. They don't think about it. All right, let's jump into some of the specifics. You've heard me talk about roofs, and I'm going to jump into how we handle moisture infusion because that's a big one. And first and foremost, think of the roof as shedding water from the building, period. It's the number one thing you can do to make your building last longer and have better, well, not the number one for better indoor air quality, but it does relate to indoor air quality, and I'll show you how in a minute. But it's the number one thing you can do for durability. Shedding the water from the house is like having a big umbrella over your head in a rainstorm. You could be practically naked, and if you've got a big umbrella, you're okay. But if you have no umbrella over your head, you better have a perfect raincoat. And perfection is not a word you see in our industry that really survives the test of time. Look at these buildings, these houses, these condominiums with no overhangs. These buildings are only 8 years old, and look at what the condition the sidings are in, the walls are in, because there's no shedding of the elements. Or this one here, the stone with the mildew and the absorption, because it's limestone, into the wall system because there's no overhang. And then this is another case. This is that house I designed back in 1981. And this faced northeast. We have northeasters. This is up in Stone Harbor, New Jersey. Look what happened because I didn't think we needed overhangs everywhere. The wind-driven rain just destroyed this house. And that's, by the way, it didn't destroy the house, but destroyed this part of the house. And that's, by the way, one of the earlier runs of Tyvek. You can see it ripped and cracked. So there are some problems there using Tyvek in its early days. But it also points out that when water falls off the roof and backsplashes against the house, it causes rot. And most buildings tend to rot predominantly at their base where they meet the ground. So shedding the water away from the house a good distance, at least 3 feet, will have a profound effect on the durability and affect other things like the mold and mildew that's accumulating inside the wall cavity and migrating into the house. So here's a great little slide from a friend of mine, Matt Reisinger of Reisinger Build. The width of the overhang in terms of the percentage of all walls which have problems. Notice 90% of the walls that have problems have no overhang. A relatively small 27% of the walls that have problems have a 24-inch overhang. We like doing even a broader overhang than that. So enough on shedding. Then the other thing you have to work on is stopping capillary action and water absorption. Joe Striebeck had a good example of this where he said, how strong is capillary action? Well, how tall is the tallest tree? Because that tree is getting its moisture all the way up to the top through capillary action. Look what happens if you ignore it. The windowsill in the upper left-hand corner where the moisture got absorbed through capillary action underneath the backside of that sill, rotting out. Or at the base of that house, you see the water falling off the roof, backsplashing against the house, that siding absorbing it and rotting it, and you can see the sill plate exposed. So that got more to the whole idea of why we have to be very careful with how we handle the base of the house, because lawn sprinklers also attack a house. So we do this rubber peel and seal membrane. This is my own home I built 20 years ago. The first time I did this is showing the peel and seal around the whole base of the house. And then we would do, in this case, a commercial grade Tyvek. And then I do 30-pound felt over that too, just for the base of the house. We just go on the Tyvek from 3 feet on up, but the base of the house needs attention. And the reason why I'm talking so much about this water management is this is the connecting of the dots between moisture and humidity control and indoor air quality. Look, in the middle of that chart is where you've got about 40 to 50% relative humidity. And look how less active things like bacteria and viruses and chemical interactions are. So managing moisture and humidity has a profound effect on the indoor air quality.
Peter, we've got a question that might be appropriate for a couple slides ago, but Rob Buchanan.
All right, well, let's hit it.
Okay. Does the combination of raised heels, which improves attic efficiency, also lengthen the eave, improving water performance for a double win?
Yeah, sure.
All right.
Let me stay on this because I'm on a roll.
Yes, you are.
All right. So the other thing that I want to point out is the importance of reducing cold condensing surfaces in the building structure. That's one of the reasons why I like spray foam so much. And no, I'm not sponsored by any of the spray foam people that say this. But if you don't have a cold surface inside the wall system or the house system, then if you've got humidity migrating from the bathroom out on a cold winter day in Denver, or from on a hot July afternoon or July morning in Austin, humidity trying to migrate in and feeling a cold surface and condensing, then you've done a lot to keep the indoor air quality good. So you understand humidity and a glass of iced tea don't work well together. You'll get all that dripping on the outside of the glass because the humidity is hitting the cold condensing surface and reaching dew point. Very similar. You don't need a lot of insulation to make a big difference. Think of the R value of this koozie on that cold soda. Very little R value stops the condensing. And that's one of the things I really like about foam. You don't have to do full thickness foam. You could just do a 1-inch spray or a 2-inch spray and then bulk fill with something else like cellulose or whatever you want. But you really stop the airflow and you prevent there from being any kind of cold condensing surfaces within the wall and roof system. So you got a humidity barrier, an airflow barrier, you get real R value, and then the better foams have a low global warming potential and they don't wick moisture either. But that's one of the safety elements of foam with regard to indoor air quality is you eliminate cold condensing surfaces and stop the flow of humidity. Another point on indoor air quality, specifically by design, is where is the pollution coming from? Ask yourself, what's the problem you're trying to solve? Instead of immediately presuming you have to put an ERV in a home, find out, let's think, well, why don't we just manage the sources of pollution in the first place? An attached garage is a major source of air pollution in a house that relies on a ducted air conditioning and heating system, because it's very often that the house will go into negative pressure and suck those fumes in from the garage. Another element from a design perspective, and this is one of the first LEED Platinum spec homes done in Texas, and by the way, it sold within a month. From the start, we thought about things from a design perspective. When we're doing the floor plan layout, you'll notice the arrow is pointing to the mechanical closet that's roughly in the center of its zone. So we had very short duct runs, which allowed us to use better ducts, but get better airflow and yet less resistance to airflow and therefore less energy consumption on the part of the air handler. So by design, we were thinking about efficiency and air quality in the placement of the air conditioning equipment. Here's another example. It's a little bit complicated, but the house on this talks about reducing duct length. The house on the left is what the air conditioning contractor wanted to do. The air handler is roughly there in the center off the hallway, and he wanted to run all the ducts, the blue ducts, delivering cool air to the perimeter of the house. You don't need to do that anymore if you have got good windows and good air sealing with something like spray foam. The version on the right is what we ultimately did, where we had much shorter duct runs, saved money, and had better airflow. So the air conditioning industry has got to catch up with what the other aspects of the building industry is doing that affects the way they design duct systems. And this is one example of that. And again, you see this thing about the air quality and humidity control. Well, let's move into it. Now let's get rid of another source of pollution, which is the humidity that comes from doing your dishes or using the bathroom or doing your laundry. A front-loading washing machine puts out less humidity than a top loader. Good exhaust fans on a timer make it so that when you take a shower, the exhaust fan runs for another 15 minutes by the time after you get out. So it really gets rid of those sources of humidity right there at the source instead of letting them migrate throughout the house. Another good point, though, is think about the ducting of those exhaust fans. Here's an example of a builder's house in Florida that was a very green home, but look at the opportunity he missed. In the upper left-hand picture, he could have run that exhaust fan right to the eave and out the eave and had a very short duct run and very efficient exhausting of humidity. But he ran it all the way up to the ridge, and there's just not enough oomph in that fan to really push that air 25 feet in a skinny little pipe like that. So it's really just a noisemaker instead of an exhaust fan. And by the way, in the upper right-hand corner, there's a big boo-boo. Don't do that. Don't have a 90-degree or 180-degree bend right outside the fan. It's not sexy stuff, but you see, we're managing pollution at its source. We're managing the way the air distribution occurs by design. And all these things make it so you have to worry less about the problems with indoor air quality, I believe. Now, by the way, with regard to kitchen exhaust, be careful with your clients about those overly exhausting ones, because they can actually make the house go negative, and then that draws air in from places you don't want to come from, the garage or down the chimney. So exhausting is good, but you gotta manage it. And talking about the house going negative, good ducts that don't leak is important. This diagram says it all. If you lose 20% of your conditioned air into the attic, not only are you throwing away money, but you're also making the house go negative. So that's why making sure your ducts are well installed and test them. We want to get below 5% leakage. That's critical. Austin was the first city in America that required duct blaster tests on every single house built because of the connection between the quality of the ducts and indoor air quality and energy use. Now, some little details I thought I'd throw in here. Think about where you're putting your electrical panels. If your electrical panel is like the one on the right, which is between an attic and a conditioned space, well, you've just made a big fat hole in your thermal envelope for humidity, molds, and pollens to migrate into the house through. The other thing, so we put electrical panels on interior partitions, not on that wall between the garage and the house, but an interior partition somewhere, so it's not interrupting the thermal envelope, and we're not putting insulation around those wires, because especially with SPF, if you put a lot of insulation around the wires, you could have an overheating problem and deteriorate the insulation on those wires. So put your electrical panels on interior partitions. And then when it comes to makeup air, here's one very simple strategy. Just use this damper that's a barometrically sensitive damper in your return air chase. It will respond to whether or not you're running the bathroom exhaust fan and then the kitchen exhaust fan, or having a fire in the fireplace, and let makeup air come in as needed and go through the air handler, be filtered and be dehumidified if needed, and then go into the house. But the point is, we're only bringing in fresh air as we need it, depending on how the house is being used. Those are good strategies. Probably, if you have the money, sure, a really good system like this, Ultra Air, brings in outside air, does filtering constantly through it for the house, and it does dehumidification. That is the primo way to go. But these other ways I told you are, I think, the foundation of indoor air quality by design and managing pollution sources. And speaking of managing pollution sources, air out that carpeting and that padding before you install it for 2 days. So the vast majority of the off-gassing can occur in the first 48 hours outside instead of inside your house. Think about things like the stovetop you're using. You know, a typical gas range wastes between 60 and 85% of its energy, and the products of combustion go up into the house. If you're building a tight house, you really need to think about this. Induction cooktops are great. About 85% of the energy goes into the food, and only about 15% is wasted, and you don't have products of conduction. Plus, they're simpler, they're safer to touch and things like that. So going back to this professor from 1981, he also taught me the value of using metrics so we could not only prioritize high-performance building strategies for our clients, but put these in perspective for our clients. So it's metrics to actually use to do good programming and then designing with. Here was an example. We looked at heat flow. We all talk about conductive R value when it comes to insulation, but there's really 3 types of heat. There's that comes from radiation, there's that comes from conduction, and that comes from convection. The radiation is the most powerful one. You can heat up a bowl of chili in a minute or 2 using radiation. It'll take you about 5 times as long using conduction and about 15 to 20 times as long using convection. So that tells us, oh, why are we venting attics in the south if the object is to cool the heat that came from radiation? You see, this is the early 80s, and this is where the concept of sealing attics came from. because we realized that ventilating an attic in Texas was like crawling into the microwave oven and blowing air on that bowl of chili. I'll just say the term, you're just pissing in the wind. That's when we started experimenting with the whole idea of sealing the attic, but doing radiation control. And we already talked about this with the colors, but let's jump to the roof because I see we have less than 10 minutes to go. When we were thinking of radiation control, we used to drape aluminum foil between the rafters before putting the decking up so we could get a radiant barrier. Then I had a building company. We got sick and tired of that, crawling all over the rafters with these big rolls of aluminum foil. So we just started stapling the foil to the decking before we put it up on the roof. And then we started gluing it to the foil, and we thought we had a pretty cool idea. So we named it Cool Ply. And then along came Louisiana Pacific, and they bought it from us. And now it's what you all know as a Tech Shield, I believe is the term. But you see the idea. We stop the attic heat at its source, which is solar radiation. Instead of dealing with the symptom, which is ventilation, we stop it at its source. And by the way, I would not do a dark roof either, but that's not me who drew up this ad. But speaking of light-colored roofs, you can't just rely on a roof with a high albedo to carry the day because roofs get dirty. This is my own house. It's a Galvalume, a pretty bright Galvalume roof, just 8 years old, and look how dirty it is. That's from the mildew and things in the air. So it's not a good reflector of heat. And by the way, never put a metal roof directly onto the roof decking. It'll just transmit the heat very, very effectively from the sun right into that house. And the roof will last, it won't last as long because if any moisture gets underneath it, it can't dry out very well. Let me show you an alternative I experimented with when I built my house. We lifted the roof off the decking so we could get a ventilated chamber underneath the roof. So the roof literally is just hovering over the house like a shading umbrella. And then we ran the lathing in angles to make sure there is continuous ventilation from the soffits up to the ridge. We've since built and simplified this quite a bit, but this was the beginning of the floating ventilated radiant barrier roof. Oak Ridge did a little study on the efficiency of this, and they found that elevating the roof off the decking is actually the stronger player than solar reflectance in terms of reducing unwanted heat gain. And the other thing about solar reflectance is it wears out. Even these coatings on these roofs they were testing were only designed to last 5 to 10 years. If you do this roof, you do it once and you're done for the rest of the life of that house. So it's a shading umbrella. And now radiation control in terms of sun shading. Yes, we do awnings above almost each and every window for obvious reasons. If you keep the sun off the glass, that's a lot more effective than worrying about the low E or the southern low E aspects of the glass. Sunglasses help your eyes, but a big broad-brimmed hat would help them even more because your eyes would be in the shade, is an analogy to think about. So we really do rely on those sun angle calculators. They help, and that's how we get to design the size of the overhangs. But the overhangs also help reflect light into the house. Look at these upper clear story windows in this slide. That light that hits the roof in front of them is reflected into this house over there in the top, and it reflects deeply into the home. So we have a really nice, pleasant space with no direct solar radiation. That's a critical one. If you're evaluating a home design anywhere where air conditioning is used a lot, look at how well the builder and the architect managed direct solar radiation. We want reflected light. We don't want direct light. We have a light-colored pool deck in the back here that reflects light into the house, but broad overhangs on the house, and you see a light-colored soffit or underside of the porch. So we're really reflecting the light into the house, but not giving them any direct solar radiation. This is a wonderful space to spend on a July afternoon. It's bright. You can read a book in there, and you're in the shade and you're comfortable. Here's another example too. Oh, and light-colored reflecting surfaces. Critically important because then you use less lighting. If you use less lighting, then you have a lower air conditioning load. So we do light-colored countertops and light-colored floors. So I'm wrapping up. Buildings shelter us so they can protect us, but they also need to delight us. Let's just play a little bit with some nice outdoor spaces we've designed. Porches. We've brought screen porches back, but they have to face the right direction, the prevailing breezes, and avoid Western orientation. Now this one does face west, but you see why. There's Lake Travis in the background. But what a wonderful living space. It's comfortable because we dealt with solar radiation. Where this one too, this is a screened-in porch off a living space. If you do screen-in porches right, they can become like outdoor living rooms, but without the bugs and with a little bit more sense of containment. So that's my wrap on using architecture to do green building and high performance building more effectively. And I'm going to leave you with this challenge. What about having this be your goal? What will it take to make your next project, whether it's a home or a building, allow the occupants to tread with a lighter carbon footprint? That's really the goal. And think this way instead of how to attain lead points, because in the end, what really matters is how we can live with a lighter carbon footprint. Thank you for listening to me today. If you want to reach me, our website is barleypfeiffer.com. I'm peter@barleypfeiffer.com. And I think we've got, 3 more minutes for a few questions if we want to go with them. Are there any questions we want to deal with?
Absolutely, and we're happy to go over great, informative, and interesting presentation. Let's see. Sean Smith is curious to know what product you would recommend to allow ventilation while still doing pest control, critter bird nest control. And I think he's perhaps referring to the raised roof idea. So how are you sealing that off?
Well, we don't ventilate the attic, first of all, and so we don't have soffit vents. This is one of those questions where I'd really have to encourage him just to call me and talk about specifics. You saw what we did at the base of the house with that peel and seal membrane. That also keeps the bugs out tremendously. And it's actually on the EPA site now as one of the 10 things to do for indoor air quality. By the way, we've only had about 2 or 3 roaches or insects in my house in 20 years. So the bugs tend to come from the ground, and so that's what we do. And then, of course, you keep your trees trimmed so they're not touching the house. You make sure your landscape people know to plant shrubs so that when they mature, there's still at least a 2 to 3 foot gap between them and the sides of the house, because bugs come into homes from the shrubs and from the trees and then from the base. So I'm going to leave it at that. That's how we handle critter control. I don't think it has much to do with the raised heel of the roof.
Are you having to put something on the edge of that roof to protect from anything getting up underneath it? And if so, what are you putting there?
We use actually a modified version of that Corvent material, which is a corrugated plastic, like corrugated cardboard, layers of it. So there's a bit of a barrier to bugs going up into the roof system because they'd have to go through that. We've also done a screen at the intake and at the ridge vent. Now, when I say the intake, there's a whole design we do now where we're venting the roof cavity, but not venting the attic. And I just didn't have time, Aaron, to get into those details. But yes, we do have some screening that prevents bugs from getting into that roof cavity I described.
Great. Michael Salito, who you may know, has a great question. In Florida, they have to build to the hurricane codes, the wind code.
I hear this all the time.
Yeah. How would you use raised gabalum roofing using furring strips to comply with that?
You connect it vigorously and well. We've done houses in Seaside, Florida. We've done houses in Houston, Texas that have all survived major hurricanes.
Mm-hmm.
You just connect it well.
Peter, are you also doing raised siding and standing your siding away from, or are you doing mostly stucco down in Austin?
Oh, no. We don't do much stucco. I don't really find stucco to be my favorite siding. In terms of creating a rain screen, first of all, if you don't have water falling on the wall, it doesn't matter. We do primarily, if you look on our website, you'll see most every house we do has at least 3 foot overhangs. So this whole rain screen argument is something that's probably come about more as people want to do these modern stucco boxes. But having said that, by using Tyvek, and I'm not trying to endorse one particular product, but I did help the folks at DuPont when they were developing Tyvek's Commercial Wrap D, which is a thicker and more robust version of their stucco wrap. So you get a very small gap between the final siding surface and the roof and the weather wrap because of that material. If we were doing, if we had a facade that was going to be exposed to the elements, particularly where the wind-driven rains come from, which in our areas in the west, northwest, or southwest, yeah, I might do some type of rain gap. But typically we rely on just good design instead, broad overhangs, and then using that commercial wrap D by DuPont.
Yeah, great advice. We have another question. How do we engage, or let's do this one. To follow up on Michael's question, what has Peter and your team done around resilience? Do you look at resiliency? Obviously, it's something important to EBA members. Have you used anything like fortified standards?
Resilience is a great term because, you heard that start coming very popular about 15, 20 years ago. And I asked myself many times, what are we trying to be resilient from? And in our area, resilience means, can the house or can the building still provide shelter and comfort without electricity? Because that's what happens here. A hurricane comes, and sure, we want the building to be strong and resist the winds and all that stuff and be resilient and be lifted above the floodplain. But the real killer for us is then they're out of power for 2 weeks. Do you have to move out of the home? Do you have to move all the residents out of the nursing home? Because nobody thought about passive cooling strategies. So to me, resilience in our area means being comfortable without air conditioning. And we've done it. We've done houses for foundation communities or advised for them where they've got houses that will get no warmer than 81 degrees with no air conditioning at all, even when it's 104 degrees outside. So we do a lot of radiation control. There we might pull the siding away from the sheathing so there's an airspace between the siding and the sheathing for cooling control. But to me, it's making it so it's comfortable without the use of air conditioning. That to me is realistic resilience in the South, at least. Mm-hmm. Obviously, in different parts of the country, we'd think about it from different perspectives.
Mm-hmm. Yeah. Peter, how do builders, or it might be homeowners that are viewing this, how do they interview their architect to make sure
they know what they're doing?
Yeah, well, I mean, how do you select the right architect? I mean, you want to build a high performance home. What questions should you ask? What should you look at in their previous projects? How do we know we're getting a great architect partner?
I think a very key element to that is ask them, how long have the houses they've been designing been around, and how have they been monitoring the performance of those homes? Because that's, I think, where I've learned most of my lessons, and they're very humbling lessons. The stuff that we all thought was groovy and great in 1975 turned out to be pretty goofy by the time we hit 1995 and going forward. So I think experience is where you gain your wisdom, and therefore you can guide your clients best. That's why I said what I did about tankless water heaters. Remember when everyone and their brother thought you had to have a tankless water heater or you just weren't green? Well, run a house for a while with a tankless water heater, see what type of added maintenance it requires, and then ask yourself, would that still be a wise way of guiding your client? So to me, it's experience, and more importantly, do they have a way of going back and monitoring the homes they do? That's why we love doing remodels as well as new homes and new buildings, because in the remodel industry, you see the results of the mistakes the original builder made. And that's my little advice for that. Check their credentials, make sure they've really been doing this stuff and didn't just take some lead class for a few weeks and call themselves a green architect, but are they really into it? I love building science, guys. I think you've got to understand the basics of physics and apply them to homes. I see an awful lot of quote unquote green homes that are just not very well designed and therefore not really green, but they've got all the components, but they don't have the good design.
Mm-hmm. And I think I hear you saying through the presentation that passive beats passive strategies.
Oh, absolutely.
Active strategies. So make sure you get the passive right first, then you can add less active strategy to it, correct?
Look, we've done over 700 homes. I would say less than 30 have solar collectors on the roofs. And these are still extremely energy efficient homes. I'm not down on solar collectors, but people just jump to that. It's the icing on the cake, in my view. Get the basics done right. That metal roof on my house saves more energy than the $30,000 solar system I have on the roof of my house. Mm-hmm. The shading of the windows on my house, actually, between the metal roof and the shading of the windows, because of the broad overhangs, saves significantly more energy than the solar panels will ever produce. Mm-hmm. And they make the house more comfortable.
So based on everything that you've learned, what are you excited about now? What excites you going forward? What are the new technologies or building approaches that you're really excited about? Is there a program you're excited about? What excites you now?
It's interesting you say the technologies. I've been railing a lot lately against technologies. I'm trying to get my colleagues who are builders and architects to think about this stuff we talked about in this talk. Help your clients make smart programming decisions. Help them make smart design decisions. A 2-story house in our climate is going to be inherently more energy efficient than a 1-story house because you have less roof area facing to the sun and less slab edge loss. There is an example of a programming decision having a pretty profound effect on energy conservation. That's a programming and design decision. Has nothing to do with the R value of the walls or how big a solar system you have on the roof, but it's just as effective. And as I've been going forward and consulting with green building programs, like Austin is really revamping their program after, 30 years now. This is what I came up with a talk I gave them. And I'd say, look, these program changes you guys are proposing, are they going to increase or decrease participation? Because if they're so complicated that they decrease participation, you're going backwards. Will the tweaks in the program make the home more marketable or less? Again, the same thing. If you do things that make it harder for a builder to sell the house, what are you really accomplishing? And then will the buildings and homes be more resilient? You brought that up. And this is my view on that. Can the house or the building be occupied in a post-major storm natural catastrophe where there may not be electricity for a few weeks? Boy, did we learn that in Houston with Harvey, where you had those people in those nursing homes dying because they couldn't open the windows and there was no good natural ventilation in the building whatsoever. And then do the tweaks in the program encourage designing for the climate, or are they really going to be requiring expensive and high maintenance gizmos? I love that ERV system that I got in my house, but there's some bad information, or not bad information, but information that shows that a lot of people don't maintain them. They don't even change. They don't change the filters. They don't even realize when the dehumidification is not working right. So be careful about relying on things that require a lot of homeowner attention. People don't tend to want to have to be slaves to maintaining their homes. And then my last point is to help educate the public about lower carbon footprint living, because everyone gets wrapped up in the minutia and they forget what is the big goal. That's the big goal.
Yeah, amen. I would like to bring up that with Team Zero, formerly the Net Zero Energy Coalition, joining the EBA Alliance, we now have the inventory of net zero energy homes that contains about 22,000 homes. Right. And that is free. If you have a net zero energy home, that is free to post your home in. It also allows us to share best practices. We want to create community around that. So whether you're a builder or homeowner or architect, you can load your projects there. I'd love to bring Gene back. Gene, do you have any final questions or thoughts for Peter?
Well, first off, thank you, Peter. That was, it is a really important perspective to have, because I think we do get caught up in sort of chasing the latest equipment or whatever the fad du jour is. And yet when you get right down to it, this is actually simple and elegant. And, one of the frustrations I've had over the years with being a production builder is we don't get to pick our lots. So we don't get to have the luxury of making sure that we have shading on this or that
Well, Gene,
elevation.
I've heard this from 1,000 production builders over 30 years. No, you don't get to pick your lots, but you can pick the exterior elevation that's appropriate for that lot.
Well, that's true.
And your client, at least you can guide the buyer saying, look, if you're choosing this front elevation, because it's got a front porch that will shade the windows, it's probably a more effective elevation to use for your lot because your lot faces west. Now, but you're in a different area than we are, but that's what we would do here in Texas.
Well, and we are customizing our elevations to get roof area where we need that solar exposure. So you're right. We do handle that with alternate elevations. But
we do it with Habitat for Humanity, and they're a pretty large volume builder, really. We get them to think about orientation very much with, are they going to flip the house, mirror the house? What front elevation are they going to use given the orientation?
Well, I love your thoughts. And, you know, when we were talking before we started broadcasting, Peter just said, I'd just like to give people some perspective of where we started, where we've gotten to, and how we could dial it back a little bit and really do a better job. So I think it was a very effective message. I heard it, and I'm sure all of our audience did as well.
Good. Well, I enjoyed doing it. Let's do it again next year.
All right.
Hopefully we'll be in person.
I hope we're in person. What are our dates next year, Aaron?
September 14th through the 16th in Denver.
Good.
Look forward to seeing everyone.
So we're not like just stuck on going to where Gene lives, but we need to salvage our contract with the hotel from this year. So really hoping that people will come, and there will be some advantages. We will still have the Ultimate Zen home for a demonstration, and really look forward to hosting people next year. And Peter, you got to come up. I will not only buy you dinner, I might even cook you dinner.
That'd be great. Look, at this point in my life, I wouldn't say I'm at the end of my career. I think I've got at least another 10 or 15, maybe even 20 years to go. But I really do like the idea of helping people stay focused on the big picture and help them not get so wrapped up in the minutia. So I'm glad that came across to you, Gene.
Well, thanks again. And is it a wrap, Aaron?
A wrap. Thanks, everyone.
Thanks, everyone.
All right. I'll see you in some of the others. Bye.